the water courses and critical infrastructure that prevents the drainage and has proposed an action plan to solve the problem. This is another similar case study which has been done in Valle d'Aosta, in the northern part, which is very close to France. And the study has been conducted in compliance with the Italian law, which is the hydrogeological structure plan. We had the study of historical landslides, the evaluation of the debris, assessment of flood and debris flow hazard, development of landslide, development of vulnerability maps, and landslide risk assessment. Of course, I make only some examples because each study is very long to explain. But here we made an evaluation of debris flow volumes. We made the geological land use map, and with the combination of the two, we had the vulnerability map. We made the hydraulic analysis. We made the calculation using the models of the quantity of water which has been flooded during the big events. And here, this is quite interesting. We have a flood hazard maps. You see in, you see in red is the area closer to the river where the risk is very high. Then in yellow we have the other area, which is the B area, which is more prone to flood, to debris flow, and the green area where the risk is lower. Okay, using this map, we could make a diagram showing which are the volume of the retention tanks which are needed to prevent these events. And this has been used to make the calculation of the retention basins, which are one of the main solutions to solve the problem. This study has been carried out in Aquila, and this is after the big earthquake that we had in Italy in 2009. We had 300 casualties, but the main problem was to find the areas apt for population transfer, because we had a displacement of 65,000 people in this area. So we had the mapping for underground cavities and landslide mapping available on a WebGIS. What is interesting of this project is that we prepared and implemented a WebGIS systems in order to make all the information available to the public. This is another case of in Romania. This is a project which has been funded by the Italian Ministry for Environment, and it's mainly for the Ilfov region, which is the region near Bucharest, which is the capital of Romania. And here also we made an analysis of the area with higher or lower probability of floods events, and we made a matrix in order to identify the most vulnerable areas. This is an example of how, again, combining the flood hazard and the vulnerability, we can have the flood risk map, where we can identify the area with higher or lower level of risk, so we can assess which are the area in which the intervention are, we have to prioritize the intervention. Sorry. Okay, these are some examples of the intervention which has been planned and implemented, which again are mainly retention basins or the widening of cross-sections of the rivers. Then we have the last case study, which is Crater, which is a project This project has been implemented with the funding of the Ministry of Environment just immediately after the big tsunami events which happened in the 26th December of 2004, and we had 200,000 casualties and big problems. And so the Italian Ministry of Environment, in cooperation with the government of Thailand, implemented this project, which has three main components. One is Rapido, which is a real-time tsunami alarm program into the Indian Ocean. The other module is SAVE, which is Study Atlas on the vulnerability of coastal areas required by rescue plans. And the third one is DATE, which is Damage Assessment by Tsunami Events on the Environment. Okay, the first module was we prepared a set of database of simulated events in order to give an immediate answer whenever we have a tsunami event, and we can make the calculation of the elapsing time of the wave height in the area concerned. In this case, for the Phuket, because the study has been done in the island of Phuket in Thailand, we can assess for each tsunami events the weight of the waves and the area which are more or less affected. For instance, in the blue area we have 1 meter of water, but in the green area we have waves which can reach 7 or 8 meters. The second part was the SAVE. So a large-scale analysis of the main coastal vulnerability has been done. We had the land use and the analysis of the land use and of the topography in order to find the most vulnerable areas. And so we had the high resolution risk and vulnerability thematic maps. Another part of the study was the analysis of the evacuation plans for the population. And the existing evacuation plans has been verified and optimized. And this is an example of using the 3-dimensional digital model. We made the analysis of Kamala Beach, which was one of the most affected by the tsunami. And here you have an example of how we studied the shortest path method and the evacuation time maps. Okay, and the last module was carried out in order to assess the damage of tsunami events using the integrated European coastal zone management principles. Okay, now let's come to the objective of the proposed work for today, which are developed as a draft basis, of course, which is to develop a methodology to be applied to regular settlements and low-income areas to prevent flood and landslide events, which is the main problem, I think, here in Brazil. Adopt state-of-the-art technology, models, GIS, remote sensing, and include an extensive capacity build planning program, and design an early warning system that will allow, through the utilization of smart monitoring network, to forecast flood events and alert affected population on time. And these are a tentative proposal for the tasks, which are the baseline assessment, hazard profiling from floods and landslide, a near real-time early warning system, and training and capacity building. Thank you very much.
Obrigada, Augusto. É interessante as sugestões já que ele fez nos últimos slides, e é bom a gente ter isso em mente hoje na parte da tarde, que é um bom ponto, uma boa contribuição para guiar as discussões de hoje à tarde.